Hey, welcome back everybody. Welcome to our online students. Today what we're going to do is take a look at stoichiometry and the gas laws. We've done the ideal gas law. The ideal gas law is PV equals nRT. PV equals nRT. This is what we refer to as our ideal gas law. Now we can rearrange this and solve for moles. We can go N is equal to PV over RT. This allows us to do stoichiometry because stoichiometry is in moles. So, for example, if you've ever been driving in an automobile and you have a sudden and abrupt cessation of forward momentum, you might experience having the airbag go off. Now, when they do this, they chose some chemicals very specifically. They have sodium azide decomposes and produces sodium and nitrogen gas. Notice it's nitrogen gas. This is a good idea. Can you imagine if the airbag was filled with hydrogen gas and this was an accident and maybe somebody smoking a cigarette? That would be bad. So it produces nitrogen gas. And the question here is, how many grams of sodium azide are needed to produce sufficient nitrogen to fill this airbag at a certain pressure and a certain temperature? So that's gas laws and stoichiometry together. So we can do this. We can do this. So what I do is I always like writing out the equation first and then trying to see if I can't fill in any information. So I have two sodium azides, okay, and that's solid, decomposes, gives me two sodium like this, and three nitrogens, okay. And it says how many grams of sodium azide. So how many grams of sodium azide? So I'm going to go X grams. I don't know what that is, but I'm going to try to figure that out. And then it gives me here some dimensions, 48 by 48 by 25 centimeters. That sounds to me like volume because we have some dimensions there. So that's 48 times 48 times 25 centimeters. And if I multiply these together, I'll get cubic centimeters. And when I did that, I ended up with a fairly large number. I had 57,600 centimeters cubed. Okay, that's a big number. And what else does it give us? It gives us pressure, and it says that pressure is 1.20 atmospheres. 1.20 atmospheres. And then we have temperature is equal to 15 degrees Celsius. 15 degrees Celsius. But as much as we love Celsius, we're not going to use Celsius. We're going to convert that to Kelvin. Okay? And to convert it to Kelvin, what do? Add 273. So add 273. And if I do the math on that, that comes out to 288 kelvins. 288 kelvins. So I've got P, I've got T, I've got V, R. R is a constant. So then all I have to do is plug these numbers in, really, and solve for N. Do I not? So my pressure here, I've got 1.20 atmospheres. My volume, oh, wait a minute. Volume needs to be in what units? Liters. So I just moved my decimal point how many spots over? 2, 3. Do I hear a 4? Going once, going twice. How many cubic centimeters are there in a liter? 1,000. It's the same as like a milliliter. So we would move the decimal 3 spots. Okay, so I'm going to go like that and call that a liter. So that's 57.6 liters. And then R is, okay, Do we have R? Do we know what R is? 0.08206. Nicely done. That was like Johnny on the spot. Okay, and then the units on that. What's the units on that? Yeah, it's plaid shirt day. Okay, liter atmospheres, liter atmospheres, mole Kelvin. Okay, nicely done. And then our temperature here is 288 Kelvin, 288 Kelvin. Okay. And then when I crunch all that out, hopefully my units should cancel and I should be left with moles if I did this correctly. So I just kind of eyeball this and I go, all right, here's liters, cancel, atmospheres, cancel, kelvins, cancel, and I'm left with moles. Now this mole looks like it's on the bottom, but it's below the line, which mathematically means it's above the line. Okay, so that's moles. And when I'm all done with this, I end up with, let's see here, I've got 2 equal to 2.925 moles of nitrogen. Okay, now I'm feeling pretty good now. So I've got moles of nitrogen here. Got moles of nitrogen. Any questions so far? Okay. Not going to interrupt me now? No, it's okay. I mean, if you have questions, it's okay to ask. Okay. All right, so we've got moles of nitrogen, and I'm going to go from moles of nitrogen to moles of sodium azide and then convert that into grams. So I'm going to say that for every 2 moles of nitrogen, I have 3 moles of sodium azide, and NaN3, okay? And then I'm going to take my moles of sodium azide. This is really hard to write. What? Yes? You're interrupting me. I should have 3 moles down here because that's a 3? Oh, yeah, yep. That would be a good idea. I should do that. And then, oh, then that should be a 2. Yep, okay. Darn students. Stop being so smart. No, thank you. Thank you for pointing that out. That was awesome. Okay. So now we have moles of sodium azide, and then just some number of grams. So I take a sodium and 3 nitrogens, I add those together, and I get 65 grams of sodium azide. Okay. And when I did all that, I ended up with 126.7 grams of sodium azide. All right, and I think sig figs might be 2 there for that one. All right, so that's how much sodium azide it takes to fill up our what do they call that thing? Airbag. Yeah, thank you. It's an airbag. Yeah, okay. Nice. Now when I saw, any questions on that? Now when I saw this, I was thinking, one of the reaction products here is sodium. You see that? It's sodium. And I thought to myself, so what if in the airbags, just for fun, what if you put popcorn in there? So like the airbag goes off, boom, right? And it's like you have popcorn in there, so it's like Jiffy Pop. You have like popcorn, a big bag full of popcorn in front of you. You've got a little bit of sodium there, right? And so you have a snack as you're waiting there for EMS to show up. Yeah, this is my $1 million idea. And if it works out, you won't see me next semester. But if I'm back next semester, then I got to come up with something different. Okay. All right, so that was taking our ideal gas law and then going into stoichiometry. We're going to try something a little different here now. We're going to take stoichiometry and go into the gas law. So we're going to do this backwards. So in this reaction, we're going to take ethanol. So go ahead and write down the question. I'm going to clean off the board here. Ethanol. We've seen this before. Ethanol is that stuff that they put in with gasoline, right? And so it is combustible. And the question here is if you have 185 grams of ethanol, how much air would you take to combust that? Or, well, how much oxygen? How much oxygen would it take to combust that? So again, we're going to write out the balanced equation for this first, and it's a combustion reaction. It's a combustion reaction. It gives us the formula for ethanol. That is C2H5OH. Okay, and a combustion reaction means I'm going to react this with what? I heard it. Oxygen. We're going to react that with oxygen. It's an O2 gas. Okay. And then we end up producing combustion products. So one combustion product would be carbon dioxide. Okay, carbon dioxide and H2O. Okay, nice. Now it's going to be a gas. This will be a gas, and that'll be a liquid. Now we also need to balance this chemical equation. And when we balance it, let's avoid the oxygens because they're all over the place. That would make it hard. What element should we start with? Carbon. Let's do carbon. All right, so I've got 2 carbons here. I'll put a 2 there. And I still don't want to do oxygens. Those are messy, so let's do hydrogens. I've got 5 plus 1 is 6 hydrogens. So I'll put a 3 here. 3 times 2 is 6. And then if I add up my oxygens, I've got 2 times 2 is 4 oxygens, plus 3 is 7. So if I put a 3 here, that's 6 plus 1 is 7. I think we're good. All right. All right. And then it tells me that I have 185 grams, 185 grams there of my ethanol. And I want to figure out my volume here, my liters of oxygen. So X liters of oxygen. How much of that is it going to use up? Okay, so I'm given a pressure. It tells me here that the pressure is equal to 793 millimeters of mercury, which is nice, but I can't use that. I need to convert it to atmospheres. And so how many millimeters of mercury are there in an atmosphere? 760. Nicely done, 760. Now if I asked you how many torr are there in an atmosphere, you'd say 760. Oh, awesome, nice, okay. So that if I do the conversion on that, I came up with 1.0434 atmospheres. And then my temperature is 45 degrees Celsius. I'm going to convert that into kelvins, add 273, and that gives me 318 kelvins. And then, let's see here. My N, I don't know, but I think we're going to figure that out. And then our volume. Okay, our volume is going to be something. We don't know what that is. And then R, that is that 0.08206 liter atmospheres mole Kelvin. Now I don't know volume, but I think I can solve for moles. I've got 185 grams, and I can convert that into moles. So I'm going to go 185 grams. And I'm too lazy to write out the formula here for ethanol. So, hey guys, do you remember how organic chemists write ethanol because they're lazy? ETOH, awesome. ETOH, nicely done. Yeah, because writing that's too much work. So that's ethanol. And there's some number of grams of ethanol. If I add up all of the carbons, hydrogens, and the oxygen there, I get 46.068 grams of ethanol per mole of ethanol. And for every mole of ethanol, I have 3 moles of oxygen. So if I do the math on this, it's 185 times 3 divided by 46. I have 12.047 moles of oxygen. So 12.047 moles of oxygen. And so now, really, I just need to put this into the ideal gas law and solve for volume. So I take my ideal gas law, rearrange it, solve for volume. Volume is going to be equal to nRT over pressure. And I plug my numbers in here, 12.047 moles, R 0.08206 liter atmosphere mole Kelvin. And then temperature is 318 Kelvin. And then down below is my pressure. My pressure is 1.0434 atmospheres. Okay. Now, I wrote all these units out. Want to see if they cancel. Atmospheres cancel. Moles cancel. Kelvins cancel. And then I'm left with liters, which is good because this is volume. Now, when I did this, I ended up with a fairly big number, 301 liters of oxygen. 301 liters of oxygen. Now, when you're doing these sorts of problems, like on assignments and such, I really encourage you to write out the units. Write it all out. Make sure that they cancel. Because as your TAs are grading these, they want to see, does this person really know what they're doing, or they're just throwing numbers here and just seeing what sticks, right? So, and then it's also a good check, because if you cross out the units and you end up with atmospheres or something instead of volume, you know something didn't work out right. So it's a way of checking. Okay. Any questions on any of that? Okay. All right, so I got to tell you a story. A while back, the wife got into jogging, and she was concerned because down on the lake walk at night, sometimes there's people out there that you don't want to run into at night. So I said, love of my life, let me get you something. And so I got her a taser. And I said, you just take this thing. If anybody gives you, they look at you funny, you take care of them, right? You just knock them down. So I got a taser. And, oh, don't turn it off. This is going to be fun. Okay. Thank you. So I got her this taser, right? This is amazing. Do you see a flaw in the plan? Yeah, you got to plug it in, right? And it's like, oh, you're not going to use that? Oh, can I use that? Yeah, okay. So I got myself this taser that I always wanted. And really what it is it's just a Van de Graaff generator. And you know, if you touch that, you get a little surprise, right? So if you, like this, here, see, oh, that's fun. So you say, so what kind of fun could I get into with this? So then what I did is I went and I got myself some ethanol, and I put it in a bottle. And I was like, oh, this would be fun. I could ignite ethanol in a bottle, but the problem I ran into is it's got a cork in there, and because I wanted the cork to go out, because that'd be fun, right? But I couldn't figure out how to light it, because it's like you light a match, stick it in there, put the cork on, too late. So somebody said, well, what if you take 2 nails and you stick them in the thing like this, and then if you use a Van de Graaff generator, it creates an electric arc that arcs across the 2 nails, and then it ignites the methanol. And I thought, oh, that could work. That would be fun. Okay, so let's try that. So, just to be on the safe side, I like you folks, but what happened last time I tried this is if you wouldn't mind, well, let's create a safe zone here. Okay, thank you. And just like right over to the side there, and see if this works here now. Okay, watch where that went. That was fun. Okay, that was nice. Okay, that was baby bear. We got mama bear here. Okay, mama bear. Ready? Oh, mama bear. What's up with you, mama bear? Have to get the ethanol here to kind of aerosolize a little bit there. Let's see if that worked. Oh, mama bear. Oh, that's too bad. Oh, dear. Okay. Try Papa Bear. Okay, we'll give this a try here. Okay. Oh, that was exciting. Oh, it's warm. Endothermic or exothermic? Sign positive or negative? Negative, yeah. Oh, nice, nice. Okay. Oh, that worked out really slick. I'm going to dim the lights here just a little bit. Okay. Okay, we ready? Let's see if this works. No? Checking your life insurance? Is there... Okay. All right. We haven't lost any students in a few months. Okay. Woohoo!